Everyone, welcome to this video. In this video, we're going to multiply binomial to binomial of an algebraic expression. Now, I'm going to present three methods could be used either or any of those three methods. However, it's up to you on your comfort on how to work out, and the answer will be the same whatsoever the method that you're going to use. Now, let's start. So let's have now a given. A binomial consists of two terms that is separated by either plus or minus. So for example, I have here x plus 3 multiplied by x plus 2. Okay, working with that, let's go with the first method. The first method is now using algebra tiles. Okay. In using algebra tiles, you need to work out with some symbolism or like the characters and its value. So we have now three main tiles. So first one is the big square. That could be x or negative x if there is a sign. A rectangle. This is x squared rather. This is x. And then a small square that will be equal to 1. So let's represent those things. So working with that, we need to get a math. We represent the dimension since multiplication is a dimensional operation. Now, working with that, let's look at now x plus 3. Now, x plus 3 could be represented by a rectangle and then 3 small squares. So, we're just going to work this out and then divide that into 3. So, this is now represented by x plus 3. Now, working on another dimension, so we have now this one, x plus 2. So, I'm going to create now a rectangle and then 2 small squares that are adjacent. So, assuming they're equal, so working, it is better if you have a manipulative. However, let's get now those dimensions. So, working with that. So I created now an area so that's working. And then on this demarcation, we can put now a line. So it will now be divided. Now working with that here, those are divided. So we have now this one. So this is now divided, assuming that this is now the perfect one. So we have now 1x squared. So we can now write x squared. Then count the number of rectangles. So, assuming this is 1, 2, 3, 4, 5. So, plus 5x. And then counting now the small squares. 1, 2, 3, 4, 5, 6. So, this would be 6. And the product, that would be now the product, which is x squared plus 5x plus 6. So, that is now the first method. Now, let's go now to another method, which is what I call the box method. So, once again, same given, x plus 3 multiplied by x plus 2. Now, we create now each cell or a header of the cell is the term. So, assuming, so we know that this is a binomial by a binomial, let's focus now on our first binomial, which is x plus 3. So, you put x as your header and then 3 here. On another one, we have now x plus 2. We put that on another dimension. So we have here x and then 2. If you know now your loss of exponent, it's much easier. So x times x. Let me use another color of pen so that it would work. So this would be x squared. Now, x times 3. So x times 3. So that would be 3x. Now going here, 2 times x. So that would be 2x. And then, last one, for the box method, 2 times 3, that would be 6. So we call this as box method, right? Now, if you have now the box method, you can now rewrite now your answer like reading a book. So when you rewrite that, so we have now the first one here. So you write x squared followed by this one plus 3x, this one plus 2x plus 6. Now, you need to analyze now your partial answer. Since there are like terms that are like terms, so we need to combine that. So the final answer is x squared plus 5x plus 6. And the product is the same while using box method and algebra tile, which is x squared plus 5x plus 6. So in the box method, it's the same. Now, let's go now on the third method, which is popular, or they use a mnemonics known as FOIL method. But technically, it came from the method of what we call the distribution method. Because it works with some structure. Now, let's go back now with our given. So if our given is x plus 3 multiplied by x plus 2, now if we have that in a structure, let me just have this as a green one. So these are the points of what you're going to multiply. So it looks like you are distributing it as well. However, the mnemonic goes like this one. Working with this one, this is what we call the first term to first term. That's why it is now F. First term to first term. Now, followed by this one, outer term. So, outer term of the first binomial and then outer term of the second binomial. Now, working with this one at this dot and then going to this direction, and this is now what we call the I, or the inner terms of the binomials. After having the inner terms of the binomials, now let's look at now continuing this one. That's why it's L, or the last terms of the binomial. Now writing now our partial product. So you need to look at now first term to first term. So you have now x multiplied to x. So the first x is here, then the other x is here. So that's what we're multiplying. Followed by outer term. So you have now plus x times 2. Working with that, this is now your x and this is now your 2. Continuing, let's go with the inner terms, which is 3 and x. So writing that, 3 times x, followed by the last term of the binomials, which is 3 times 2. So working with that, plus 3 times 2. Now, we can now get now the product using the laws of exponent. X times x, that would be x squared, plus 2 times x, that's 2x, plus 3 times x, that would be 3x, plus 3 times 2, that is 6. Working with that, we have now like terms, 2x and 3x. So adding that to simplify your answer, we have now x squared plus 5x plus 6. So those are the three methods. So let's have now another example that involves now negative number. So, or negative in the part of the binomials. Because there will be a different story with that. I'll do as well the three methods, but let me expedite the process. Okay, let's have now the given. For example, I have now here x minus 3 multiplied by x plus 4. Now, let's go with algebra tiles. Now, working with algebra tiles, once again, we need to look at this one. So, x is represented by a rectangle. And then, I need to look at now 3 small squares. Assuming they're equal in size. However, this is negative. So, I need to put a negative inside the small squares. Now, next, let's have now the another factor, which is x plus 4. X and then 4 small squares. Oops, let me fix it. I think that's better. Since it's positive, that's way better. Now, you can now assume now on your product. So, working with this one, no, I can't use blue. I should use black so that there will be uniformity. So here, and then the dimension of this one. So working with that, oops. And then this one. Then connecting all those things with their boundaries. Okay. However, we need to work this out. A positive, remember that this is x minus 3 and this is x plus 4. Now, positive, which is this one, x multiplied by a negative. So this would be negative. Right? And then, on an aspect, this is also positive. So this would be negative. So all the small squares would be negative. Now, there would be an analysis that you need to look at. That's why I don't use another color because this is the analysis. If there are pairing of a positive and a negative, you need to remove that. So I'm going to remove this one and this one because that's a positive and negative. They will be negating each other. It would be 0. Another one here and this one. And then another one here and this one. So what is left now would be the answer. So we can now write our answer as x squared plus x, then count the number of small squares, that is minus 12. Make sense? Now, working with that, let's go now to another method, which is the box method. Again, since we're multiplying it, a binomial by a binomial, so the given is x minus 3 and then x plus 4. Once again, you create now a 2 by 2 table or what we call the box. And then put a header, x and then negative 3, x then 4. Multiplying that, x times x, that would be x squared, negative 3x. 4 times x, that's 4x. And this is negative 12. Writing now our answer. So we have now x squared minus 3x plus 4x minus 12. Okay, with that, since these are like terms, so negative 3x plus 4x, we need to subtract that, their numerical coefficient. So x would be plus x minus 12, which is the same answer here. Now, let's go with the FOIL method. Last one, FOIL method. So, once again, copying now the given, which is x minus 3 multiplied by x plus 4. Now, once again, first to first, x times x. So, I'm going to rewrite that as a starting learner of algebra. And then x times 4. Here are the tricky part. You need to get now negative 3 times x. So, negative 3 times x followed by negative 3 times 4. So, you get the sign. Now, working with that, so we can answer x times x, that would be x squared plus 4x minus 3x minus 12. Since there are like terms, we can have now x squared plus x minus 12. So, in sense, there are 3 methods. However, looking at that, all the answers are the same. You're able to see whatever method you're going to use, all the answers would be the same. With this, thank you for watching this video. Hope it gives you some learning about multiplying binomial to a binomial algebraic expression. Thank you for watching. Have a great night.